Hello guys, welcome to the Network Plus course. I'm Ishtaq Ahmed and today we're going to talk about network ports and protocols. So we will be understanding different fundamental blocks of different protocols like HTTP, HTTPS, FTP, SMTP and DNS protocols. So let's start this video. If you like my video, please also like and subscribe. It took a lot of effort to create this course. So let's start our video. So first of all, we will. What is a network communication? So a network communication is like when two devices communicate to each other in a network. So we got two essential components in a network communication: the ports and the protocols. So I will read just this one. The ports act as a virtual endpoints, similar to apartment numbers, identifying specific applications or services on the device. So it's like the address of an apartment. So it tells us what kind of services does a different device give us. Like if I want to give an example of a home, of a room, like we have a hair dryer in one room and another application in another room. So these are like services. So ports have different services. So there are different ports and they give different services. And then there are protocols. They are the rules. Are we can say the language. They are the language of two different endpoints. So different devices can talk to each other. So they ensure that different systems can understand each other. So if we put them together, like ports and protocols, it creates sockets that can be used as seamless exchange of information across the networks. So there is an example, like we have the postal service analogy. So IP address is like a building address and the port number like apartment number. So as we explained it here, just say the postal service needs both a street address and an apartment number to deliver a mail to correct recipient. Network communication uses IP addresses and ports to identify both the device and the specific services. So as you see, IP addresses are like address of a certain device in a network. So we can like get the device with different IP addresses. So we will move on to the next page. So here we understand the network protocols. So network protocols are established rules that govern how data is exchanged between devices. So there are different kind of protocols, like we have HTTP protocols, FTP protocols. So here we have given example of an HTTP protocol. So we use HTTP protocols in web browsing, like we search any website on Google. We are using the HTTP language, so both the client and the server understand the HTTP protocol language. So they transfer data in this communication type. So, like a common language facilitates communication between people, protocols ensure different systems can understand each other. So it's like a language, like we use English language to communicate with you guys. So the different devices or networks use different kind of protocols to talk to each other. So they also use we have a layered architecture of TCP/IP model to organize the protocols into layers, like to simplify network standards. So here we have a hint that without the protocols, devices won't understand each other's message. So yeah, without the language, you cannot understand me, I cannot understand you. So it's the same with the devices. Like we have let's say we have a HTTP device, a client device, and a server. So if we get a wrong protocol from a server, then the client side will not be able to understand. So we will not get our data on our browser. So that's it, the HTTP protocol. So we will go to the next page. Yeah, TCP/IP model. Here is an overview of some of the layers of TCP/IP model that we use nowadays in the networks. So it's a conceptual framework that organizes network communication into four interconnected layers. So we got the first of all the application layer. it is the closest to the end user, like to the client. So it provides network services like HTTP, FTP, SMTP. So HTTP, Hypertext Transfer Protocol, FTP, File Transfer Protocol, and SFT, Simple Mail Transfer Protocol. So these are the protocols, the example of three protocols that are used in application layer. We use them in like web browsers and email clients. Then we have the second layer of TCP/IP model, that is the transport layer. So it manages end-to-end communication. So it ensures the reliable delivery, and it uses the protocol TCP and UDP. So each layer in the TCP/IP model have its own protocols. So it uses that protocols to communicate on the other end with the same system or OSI layers. So next we have the internet layer. It handles addressing and routing. So it kind of determines the best path for data. It uses the IP addressing to actually identify a device on a network so it can send the packets to that device. So then we have the lowest layer, physical hardware, like routers, switches on a hardware level, we call the link layer. It transmits data into frames. So it transmits data in a form which is called frames. So also it is this layer is used to detect errors. So we have different examples as well. So in the application layer, it is used in web browsers and email clients. So then we have a transport layer which uses the TCP and UDP protocols. Then we have internet layer which uses the IPv4, IP addressing version 4 and IP addressing version 6. So these are some IP addressing variants. And then we got the link layer, for example, Ethernet and Wi-Fi. So from application layer to transport to internet to the link, so the data travels from like, as you can see at the bottom, like data travels from the application layer to the link layer. So I hope you guys understand that. So we're gonna move to next one. So here we have some application layer protocols. We have defined these three commonly used protocols in more detail. So application layer is a top layer in a TCP/IP model, providing network services directly to the end user applications. So here we got a HTTP protocol, which is a hypertext transfer protocol. It enables communication between web browser and services, as we discussed this before, used for web browsing. So we know that. So then we got the FTP protocol. It's a file transfer protocol, facilitate file transfer between systems. So on Ethernet, when there are like a lot of different devices interconnected with each other, so we can transfer files from one system to another system. So we use that FTP protocol. So then we got the SMTP protocol, Simple Mail Transfer Protocol. As we all use our Gmail accounts, Google Gmail accounts to receive email, it uses the SMTP protocols. It handles sending and receiving of emails. Also, the server that stores our email uses the SMTP protocol. So here we got the example at the bottom, like web browser, then to HTTP, web servers, and content. Like web browser uses the HTTP protocol with the web server to get our content. So we can see our content on the browser. So okay, let's go. Okay, we got the transport layer. It was a second layer in the TCP/IP model. It uses the TCP and UDP protocols. The transport layer manages end-to-end communication with two primary protocols. These are like two primary protocols for communication at the transport layer. So first of all, the TCP, Transmission Control Protocol, like it controls the transmission in a communication, like controls. So it's connection oriented. So what that means is like it need a dedicated connection with the server to transfer the packets on the network. So it's highly reliable. So it like its reliability is very good. Like we receive our packets at the end. So its speed is a bit slower because it needs a dedicated link, and also we use in the web browsing, email, and file transfers. So we got the UDP, User Datagram Protocol. So connection type is a connection less, so it doesn't need a dedicated link. Like it doesn't confirm that the client is connected to the server. So it's unreliable. We can lose our like if we are doing a video stream or online gaming, we can lose our video because of some. So its speed is fast, so it's a fast network. We use it in the video streaming, online gaming, and DNS domain name server. So which is standard domain server. So let's go to the next one. So what is an IP? So Internet Protocol is a core component of Internet layer responsible for addressing and routing data packets across networks, determining the best path for source to destination, encapsulating data into packets for delivery. So an IP is like a address of a certain device on the internet. So it does all of these things. So IP is responsible for delivering packets to correct destination while higher protocols handle the specific communication needs of application. So it's like it's responsible for like delivering packets from one end device to the another on a large network. Also, the small one, we use the IP address. We got the IP addresses for our Wi-Fi routers, our switches, our computers, our NIC cards, etc. So we got two variants of IPv4 and IPv6. So the original one was the IPv4. It address size was 32-bit, and address format was dotted decimal. As you can see, we can see sometimes this kind of address on our Wi-Fi router. Also, this IPv4 variant can hold up to 4.3 billion devices, and it was developed originally, but it ran out. Like we ran out of address space, and we then move on to the next variant, which is a bit large, vastly large, and future focused. So we can like control a lot of devices with IPv6. So it was addressed as action. IPv6 was developed to address the exaction of IPv4 addresses and protocols, improvements in routing efficiency and security. So it was the next version of the IP address. So what are the network ports? Network ports are virtual endpoints that identify specific application or services running on device within a network. So network ports are like port 80 used for HTTP as we have here. So we cannot use the FTP port to send data to the HTTP port. So it's only used like both hands are using the same language to understand each other. So complement IP addresses device identification with port numbers, service identifications. So allow multiple services to run on a single device simultaneously. Enable independent communication between applications and facilitate bidirectional data flow between devices. So bidirectional mean like many devices connected to like endpoint. Many endpoints can receive the data from a same port, HTTP port. Like a server can serve a lot of clients using HTTP protocol. So HTTPS is like a secure protocol. It's a upgraded version of HTTP protocol. So we use the HTTP protocol in the browser. Like we also use the HTTPS protocols because they are secure for the websites. Also, we got the SMTP protocol for the email and the FTP protocol for file transfer. So next we have port number classifications. So these are good to know. Actually, they come in the net plus exams. So from 0 to 1023, well known. These are well known ports. Like we use in this range. These are from common network services. Are controlled by IANA, Internet Assigned Numbers Authority. It's a organization for the unique identifiers for the devices on the network. So we got the HTTP protocols, which uses the port 80, HTTPS, which uses the port 443, and FTP, which uses the port 20 and 21. So we got registered ports which range from like 1024 to 49,151. So these are like non-user ports can be registered with the IANA. So for example, we use them in like SQL servers like 1433 and MySQL 3306. So 3306. Then we got the dynamic ports. So they got from the range of 49,152 to 65,535. So they are not assigned by IANA, so used by client application. Also the client application. So they're dynamic, like we run a server from our PC, so we can assign our dynamic port to that one, and we can use that dynamic port to connect on another device. So they are not like assigned by IANA. So let's move on to the next page. Here we have well-known ports. What are the well-known ports? Ports from 0 to 1023 reserved for standard services controlled by IANA to prevent conflicts. So like we use these common examples. We use these services like HTTP service for web browsing. HTTPS is also for the web browsing, and FTP control, the control protocol, which is used for controlling the file transfer on different devices. So purpose of these classification is standardized assignment, system-wide uniqueness, and common service identification. So we got these ports. Now let's go to the next page. Oh, we got registered and dynamic ports. So registered ports range from 1024 to 49,151. So these ports can be like registered with IANA by software developers for specific applications. It helps prevent conflicts and provides standardization for less common applications. So for example, Microsoft SQL Server port 1433 and MySQL port 30. So you can like register different kind of ports between this range. Like we can have a port like 1055, and we can use it for like web applications. So we have to like register it with the IANA to be used on the browser. So then we get the dynamic and private ports, which range from 49,152 to 65,535. So they are not controlled by INA. So you can use it when you have like a private, you want to define a private port for users to connect to your application. So the port you defined will also the client should need to connect to only that port, so then your application would work. So OS dynamically assigns an available port. So assignment is a temporary, so it can change, you can change it later also. And client server connection index, so they are kind of client server connection identifier, you can set them. But for standardized version we use the port HTTP port 80 for client server communication. So let's go to the next one. We got the sockets. What is a socket? A socket is a unique combination of an IP address and a port number. So what this enables us to get multiple distinct communication channels on a single device. So a unique identification for each active connection and correct routing of data to appropriate application. So we got the visualization of a socket, like we got the device, like it could be a server, the server IP address, and then we got the port, like this real protocol, HTTP protocol, have a, like you can see there is IP address and the port number. So we use the 80 with the HTTP, and as you can see with the HTTPS we use the 443 port with the IP address. We got the DNS, domain name server, and also the SSH protocol, secure shell protocol, which is also used with the IP address to create a unique identifier for different devices. So, reminder is each socket represents a unique service on a device, allowing them to communicate independently. So let's go to the next page. We got common network services. So we got different kind of services on our network. So network services rely on specific ports and protocols for communication. So like we see an HTTP protocol for the uses for the web pages. So it uses the port 80 and the protocol TCP. So then we got the HTTPS. It's for the secure web browsing, and as you can see we use the port 443 for that, and the protocol is TCP. Then we got the file transfer protocol FTP control, so it's command and control for file transfer protocol, so it's command and control for that. So we use the port 21 and the protocol TCP. Then we got the FTP, data file transfer protocol. So it uses the port 20 and the protocol TCP. Then we got the SSH, secure remote access. For secure remote access, we use the port 22 and the protocol TCP. Then we got the SMTP, yeah. Then we got the SMTP email messages. So it uses the port 25 and the TCP port 25 and the TCP. So then we got the SMTP. It uses the email messages for use for email messages, and the port is 25 and uses the protocol TCP. So these are the some services that we get on the network. Let's go to the next page. So we get the web and secure communication ports. So key protocols that enable web browsing and secure communication. So HTTP port 80 protocol TCP for web pages without encryption. So then we got the HTTPS, which is a secure, which uses the port 443 and the protocol TCP. It is encrypted HTTP for security. Yeah, it's encrypted, so the data comes encrypted on the network. So it uses the SSL or TLS encryptions. Then we got the SSH, secure for secure shell for remote access. So it uses the port 22 and a protocol TCP. It is used for like authentication and command execution. So these are the favorite secure communication ports. So we got some security implications. Like open ports can present vulnerabilities, and we should always like close the unnecessary ports for security and use authentication for the access control for remote devices and also the other network devices we have. Next we have file transfer and email protocols. So FTP file transfer protocol. We got actually two ports inside that protocol. They use the first one is like control, which uses the TCP protocol with the 21 port, and for data we use the TCP protocol and the port 21. So for the first one, control port, it is used for command and control of file transfer. So it takes care of all the like control of how the files are transferred from the one device to another. So we usually connect to the port 21 for that, and then for actual file transfer we use the data port 20. Then we got the SMTP protocol, simple mail transfer protocol used for the Gmail accounts. So SMTP is used for sending emails, messages across the network. It facilitates the transfer of mail between mail servers and from servers to clients. So yeah, we got the servers having our emails, then it uses this protocol to send it to our computers in a browser. So for emails, we use the SMTP with the port 25. So it handles the delivery of email messages based on the recipient's addresses. So it uses also the IP address. So to transfer that, security often used with the star TTLS to encrypt communications. So at the bottom we have like a little bit of demonstration like client and server using the FTP protocol. So it works in both ways, like client send files to the server, server send back to this one. So also the sender to the recipient, and then he can also send back to the sender. So it's a two-way communication. Then we have some network considerations, like understanding the network pose is crucial for maintaining robust network security. So firewall function control network traffic by blocking or allowing specific ports. So firewall it is used like we have firewall here. So let's say we got this port HTTP port 80. It's want to send data to a external network. So if external network uses another kind of protocol or port to like for the data communication, then the firewall will block this request. So uh, security vulnerabilities, open ports provide potential entry point for attackers or hackers. They're the same. So best practices close unnecessary ports and secure open ones with authentication. So these are some common security misconceptions: leaving all ports open for convenience, neglecting to update firewall rules, implementing layered security approach. So yes, go to the next one. Yeah, these are like practical application for these protocols. Like web browsing, we use it like every day. When you visit a website, your browser uses the HTTP port 80 and HTTPS port 443 for secure communication. So these protocols handle the request and response between your browser and the web browser, so client and server. Then we get the file transfer. It uses the port 21 and port 20, as we explained it before. Control port sends commands, data port transfers the actual files. Then we got the email for sending emails. Your mail client uses the SMTP port. Then simple mail transfer protocol handles the delivery of email messages from your mail server to the recipient server. Then we got the secure shell for secure remote access, so SSH for port 22. So SSH creates a secure encrypted connection to remotely access server or devices. Okay. Then we got the DNS, domain name server, for translating domain names to IP addresses. So it is very good. Like we got the google.com on our web browser. So at the below that we also have an IP address written. So we translate the domain name into the IP addresses. So it enables us they are like really good for the reading perspective, so we can remember, we cannot remember all the IP addresses of different browser websites on a browser. So domain names are easily to remember, like google.com, yahoo.com, gmail.com. So that's kind of thing. So it's also very user friendly. So next we got the summary of what we learned today. We learned about protocols, which are the fundamental rules to govern how data is exchanged across network, ensuring orderly and understandable communication. So then we talk about ports, like different ports, HTTP, FTP, how they work, how they connect to each other, and how they like direct incoming and outgoing data in a correct applications and our services. Then we got to know what our sockets are, how they are created, their combination of IP address and port number, and they are used for distant communication channels on a single machine. So key insights are here, like understanding these concepts is essential for network security and identifying potential vulnerabilities. Ports and protocols work together to enable the seamless exchange of information across networks. Firewalls and security measures rely on proper port management and protocol compliance. Then common protocols and ports form the foundation of internet services. So I hope you guys like my video. Please like and subscribe to my channel. If you got any question, please ask in the comments. I will be very happy to answer all of those questions. If I did some kind of mistake while creating this video, please help me solve that in the comments. So hope you guys like my video. See you in the next one very soon. So I did a lot of it took a lot of effort to create this one. So see you guys and have a nice day.